Hello everyone, welcome to this video. In this video, we'll be solving second question from exercise 9.4. Right, so the question here says that we are given the series 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on, right? And we wanted to calculate what is Sn, what is the sum of first n terms of this series. Now notice that this is not an AP, right? This is not a GP, right? Because the common difference and common ratio could not be found in this particular case. So what we can do in order to calculate Sn, we know what is Sn. It is summation of the nth term. When you add up all the terms like this, so you would have the value of Sn, which is the sum up to first n terms. So for that we are required what is our nth term. So can we generalize it from the given series? Yes, of course we can. So let's see. So from here you can clearly see your A1 is what? It is 1 into 2 into 3. What is your A2? It is 2 into 3 into 4. What is your A3? It is 3 into 4 into 5 and so on. So from here can we write our An? So our An, what would be that? You see here we have 1, here we have 2, for 3 we have 3. So for n we would have the first term as n. Right? What about this second term? When we have the index as 1, our term is 2. So we can write it like this, 1 plus 1. For our index 2, our term is 3. So we can write it like this, 2 plus 1. What about 3? For the index 3, we have the term as 4. So we can write it as 3 plus 1. So that means the next term for the index n could be written as n plus 1. Right? What about the last term here? For the last term, you can see for the index 1, we have 3 here. So you can write it like this, 1 plus 2. For the index 2 here, we have 4. So you can write it like this. For the index 3, you have 3 plus 2. So that means in each of the term, if you add 2 times to the index, you get the term which is required here. So that means you can write n plus 2 here, right? So this becomes your nth term in this case. So you can solve this one and you obtain this expression. Now in order to calculate the sum up to first n terms, you have to take this summation. Now notice that again this summation, in this summation we are using the index k instead of n, and we are saying k varies from 1 to n. So your last term would be n and your answer would be in terms of n only, right? K is just a dummy variable. So you can substitute the value of ak here. So what would an is known to you, so what would be ak? It would be k cube plus 3k square plus 2 into k. So you can substitute it here, right? And then you can separate out the summation. So when you separate out the summation, you would have summation k cube plus 3 summation k square plus 2 summation k. Why this is so? Because the first term would be like this, 1 cube plus 2 cube plus 3 cube and so on, right? The second term would be like this. You have 3 1 square plus 3 into 2 square plus 3 into 3 square and so on, right? So that means you can take out this 3, so you would be left with 1 square plus 2 square plus 3 square and so on. And in the last term you can take out similarly 2 outside and you would be left with 1 plus 2 plus 3 and so on. So that you can write it like this, right? So once you have written your expression like this, now you know what is the formula in order to calculate the sum of cube of first n natural numbers. It is n plus 1 divided by 2 whole square, right? What is the formula to calculate the sum of square of first n terms? It is n plus 1 2n plus 1 divided by 6, and for the first n natural numbers the sum is calculated using the formula n plus 1 divided by 2. Now what you can do, you can just simplify the terms, right? You can take n plus 1 common from all the 3 terms and you can take 4 outside. So because here 3 and 6 they are cancelled by 2, correct? So here you have 2 into 2 which is 4, so you can take this 4 also outside. So here you are left with 1 power of n and 1 power of n plus 1. In this term we have taken this thing outside, and even you have to multiply it by 2 above and below so that it would become 4. So you are left with just this thing, 2 into 2n plus 1. Here also in order to make it 4 you have to multiply it by 2 on up both in the numerator as well as in the denominator. This is taken outside, so you're left with 4, just 4. right? So now next what you can do, you can simplify the terms, you can multiply the terms here, you can multiply the terms here, and you can write this 4 as such, and then you can just add up the common like terms, right? So that you have this expression. You can now factorize this expression in order to get n plus 2 and n plus 3 as its factors. So this is your answer. So I hope you understood this question well. That is it for this video. Thank you for watching.